Hello everyone, IG Bits welcoming you all for happy learning. Today we shall see some of the trigonometry applications and then try understand like why trigonometry is so powerful, isn't it? All the viewers, new joiners, whoever might be in today's class, everyone, please feel free to subscribe the channel, and I'm hoping that you are going to give a helping hand to share our YouTube channel information to the your extended friend circle to help each other. This is a minimum help that everyone can do as a courtesy to get benefit both parties, isn't it? Please do visit our channel at the rate IG Bits in YouTube. Thanks for all you guys support. Keep learning. Let's look at a basic fundamental definition of trigonometry. Okay. So the word trigonometry comes from Greek word. Trigono means triangles. Metry means measurements. So put together trigonometry means a triangle measurement. The branch called trigonometry basically deals with the study of a relationship between sides and angles of the right angle triangle. If you take a right angle triangle, we know that a triangle means like we have three sides and three angles, isn't it? So the relationship between sides and angles is what we are going to do a detailed study with help of trigonometry. Okay. In the graphical representation, trigonometry is branched out into two parts: trigono and then metry. Trigono means a triangle, metry means measurements. So trigonometry means like a triangle measurements. Let's look at some of the applications of trigonometry. So trigonometry is very widely used in science and engineering field, and trigonometry used in astronomy precisely to find out a distance between the stars and the planets. That shot by you sitting in a earth, right? You are not going to go there to the stars to find out the distance between stars and then in moons, right? So how you are going to measure the distance between the stars or distance between the planets or stars and the planets, that sort of applications can be achievable using a concept of trigonometry. So how the beautiful, right? You can also see all architectures that we are going to build today, right? Where we are applying a trigonometry, and then study of waves and properties is a place where you can see widely application of trigonometry. Trigonometry can also applied in navigation field and aviation field, right? And then one more precise part is, okay, study of depth of sea. So trigonometry is used in understanding and then find out a depth of a sea. Okay, so and then there are many more applications. So this is why trigonometry is one of the motivation, a topic that everyone should understand, enjoy the feel of all the applications related to trigonometry. Let's look at some of the examples in little deep dive to understand in detail of applications. Let's say I have a tree. With respect to ground, it's in vertical direction, isn't it? And then you are standing somewhere else and then trying to see a distance tree. You don't really know that how far the tree with you, right? And then you now see the distance horizontal line is what you have drawn, which is of the distance between the observer like you to a tree, right? So if you are trying to see a top of the tree, like a tip of the tree, so that means like the line that you are showing now is basically a line of sight with respect to you. You are actually seeing a tree at a top edge, right, without you movement, isn't it? So now question is, and then you see this is called as a angle of elevation. If you're looking at horizontally, then your line of sight would be on the horizontal line, but you are making an angle to try see height of the tree, and hence the angle of separation between the horizontal line and the line of sight line is called as a theta, which is called angle of elevation, isn't it? By doing that, so you will be able to find out the height of the tree, right? If you know the angle and then horizontal distance of, and then make use of these two, you will be able to find out height of the tree using trigonometry, right? This is one of the application. Let's say you are in airport, okay, and then you are seeing that like flight is trying to land. So what is important thing is like you have to figure that out, like how speed at which the aeroplane is actually approaching for landing, and then you sitting at the control system, you have to keep monitoring what is the current height versus like how gradually decreasing the height, and then whether it is properly landing on ground, those sort of measurement that you have to do dynamically. You agree? So let's say you are sitting in the control room and then trying to see two things, right? First of all, the horizontal distance, and you can also see like your line of sight while the aeroplane is prepared to land. These things can be seen. What that means is from the measurement how far the distance with respect to you, and then you can also see what is the current height at that instance. Since the target is moving towards to preparation for landing, obviously the distance, I mean the height uh, is gradually decreasing in order, isn't it? So that you have to monitor with help of trigonometric functions. So assuming this is the height with respect to ground at the current instant, and then you draw a horizontal line, something like this, okay, and then you are trying to see now the approaching flight as a target with a line of sight, right? The angle of separation between horizontal line and then line of sight is what you say like angle of elevation, and then this one is what actually we are talking about, the horizontal height, the vertical height, that is in height with respect to ground, right? At any instance you can find out your angle, and then your horizontal line, your line of sight, and then your height. So if you look at this is forms a right angle triangle, isn't it? Because of this is a right angle triangle. So trigonometry basically talks about a relationship between sides and then in the angles. Make use of those, you will be able to find out height dynamically, and then the rate at which it is approaching to prepare for landing. Okay, you can see safety landing, right, because the passengers are there in the plane. So definitely a accurate mathematical calculation is very important to act upon, based out of the condition or situation. So this is a live example where we are gonna use trigonometry functions, ratios, okay, tools, techniques, make use of trigonometry, how applications are being built in the real time. Let's take one more application. Suppose you are on your building and then trying to see a water pump water pump which is in your compound, right, but in front of your building, but you are at top of your building, so you are trying to see it, right? So now what you are seeing is like you're seeing towards to direction downwards, right? Your line of sight is a downward direction. If you look at in a horizontal line is a reference line, if you can draw, then with respect to horizontal line, your angle is what you can call it as the separation between horizontal line and line of sight is angle of depression. Angle of depression, okay, which means that you are looking at is a downward direction. But one thing that we have to see, we have a horizontal line, hypotenuse, and angle, that is a vertical line, it's called a right angle triangle, right side. So make use of this right angle triangle, and understanding sides and angles relationship means a trigonometric application, right? So you will be able to find out a height of the building or distance, you know, distance between the house and then this water pump. These things can be measured easily, isn't it? Let's say suppose you have a high power transmission lines going on your you know um, side in the colony. So what happens is like you might have a think of like, oh man, this is very tall, but how do I know like how much tall it is? So do I need to go and actually measure vertically by climbing in the the tower? I don't think so, right? That is where trigonometry can help you. How? So let's say you are standing here, and then you know the horizontal level how far you are, and then you're trying to make an angle of elevation with respect to horizontal line, right? If your line of sight is actually trying to see a top of your tower, and then angle of separation is what you can easily find out because that is what you are observing, and with which you will be able to find out the distance, between your horizontal line to your the top of the tower plus your height can gives you the height of the tower, is it? This is another application. I say here high power high power tension, electric, the pole, but you can also look at same application can be leveraged for finding a Eiffel Tower if you're trying to use trigonometry. Likewise, this is another example where you can see application of trigonometry. So I borrowed this picture from internet, but if you look at this example gives a demonstration of how trigonometry is going to help us to identify the distance between planets and star, things like that by sitting you experimenting from Earth, right? This is another beautiful example of application of trigonometry. Is it not astonished? So one more example. So let's say like you were standing on a tower and then trying to watching the car which is approaching to the building, right? So the observer and the line of sight and the angle of depression and the right angle triangle formation, right? Again the same application, but all these techniques is going to help you to measure the how yet what rate that car is actually approaching the building, or if it is a stationary, how far the car with respect to building. These kind of things can also be measured. So without you going, uh, you will be able to calculate all this, right? Your computing knowledge is becomes like a more powerful with the help of a trigonometry. I'm sure I think you are all agree with this application. When we study trigonometric ratios, the five different angles in right angle triangle is what we are going to mostly deal with, which is what? Sin theta, cos theta, tan theta, cosecant theta, secant theta, and cot theta. We will see them in the detail, but this is what I think mostly we are going to study, and then make use of these things. You are finding lot of problem solutions. Thanks for watching. Please like, share, subscribe, click on bell icon, and leave the comments. Once again, thank you all for your valuable time spending for learning. Okay, we will continue our learning to cover the remaining topics of trigonometry. Stay tuned to next session. Have a good day. See you again in next class.